For this FRQ, we have a figure for R. It's the shaded region in the first quadrant bounded by the graph of y equals 4 ln of 3 minus x, the horizontal line y equals 6, and the vertical line x equals 2. Part A says find the area of R. So to find the area, we're going to integrate from 0 to 2, and we're going to do top minus bottom. So top is going to be 6, and then the bottom will be this curve right here, the y equals 4 ln of 3 minus x. So here's the setup. I have the integral from 0 to 2, and then 6 minus 4 ln of 3 minus x. So on your calculator, press y equals, and then type in the equation 4 ln of 3 minus x into y1. To evaluate the integral, we're going to go math 9, and then we'll go 0 to 2. So the integrand is going to be 6 minus the function we typed into y1. So you can pull up that function y1 using alpha trace, and go ahead and press enter. So we get 6.817, and that represents the area of region R. Part B says find the volume of the solid generated when R is revolved around the horizontal line y equals 8. Here's a little sketch. We have y equals 8, the axis of rotation, and then you have your shaded region. Notice between the shaded region and the axis of rotation you have a gap, indicating that this is going to be using the washer method. So now we need capital R and lowercase r. To get capital R, you go to the further part of the shaded region, and for lowercase r, you go to the closer part of the shaded region. Capital R corresponds to that natural log graph. Also, I want to make a note, we're rotating around a horizontal line, so this is going to be a dx problem. So for r, we want the equation written as y with respect to x. So for capital R, I have the y equals 4 ln of 3 minus x, so it's in the form of y with respect to x. For lowercase r, wherever you draw it, you get a constant value of 2. And finally, to finish up the expression for capital R, you can think of it as top minus bottom. So if you look at it, you have top, which is 8, minus the bottom, which is the curve. So I wrote that right here. So to set up the formula using the washer method, it's the integral of pi capital R squared minus pi lowercase r squared. You can factor the pi out, so then you have your integral. It's a dx problem, so you look at the shaded region, and in the x direction, it exists from 0 to 2. So those are our limits, and here's our setup. So we have pi, the integral from 0 to 2. Here's the expression for capital R squared minus, and then you have lowercase r squared dx. Okay, and last we're going to plug this entire thing in. So I have pi, and then math 9, we're going to integrate from 0 to 2. So first you want to plug in your capital R, so we're going to go 8 minus, and then we have that equation as our y1. Make sure you square that, and then we're going to go minus lowercase r squared. So we're rounding to 3 decimals, so your 9 would get bumped up, which then bumps the 7 up. So you get 168.180, and there's our final answer. For part C, it says the region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a square. Find the volume of the solid. So for volumes of known cross-sections, since this is perpendicular to the x-axis, it's going to be a dx problem. For your shaded region, it exists from 0 to 2 in the x direction. So that's why the setup for the volume is the integral from 0 to 2, a of x dx. A of x represents the area of the cross-section, and the cross-section is a square. The area of a square is the side squared. So let's go ahead and look at the region to identify an expression for the side. We're going to do top minus bottom. So the top is 6, and then we're going to subtract the bottom, which is the natural log equation. And this whole expression is the side of the square. So to plug it in, you just do the side squared, which represents the area of a square. Okay, so we have the integral from 0 to 2, and then we're going to do 6 minus, and that is our equation for y1, so we'll call that function up. So make sure you have the whole quantity squared, and you end up getting 26.267. So there's your final answer. Okay guys, thanks for watching, and if you don't mind, please like this video and subscribe to Math with Yosh. Thanks!